Okay, let's talk about how to transform motion graphs. What we have here is, this is the typical way you're going to see it on the AP test. This line represents the time axis. This is 0 time, and this is the last time we look at, so beginning time, end time. And this is D for distance. And so this line also represents, think of this point right here as the origin. So this is positive distance values and negative distance values, and all we have are positive time values. The same thing will be true for velocity, positive velocity, negative velocity, time 0, outwards. And here we have the same thing for acceleration. Positive acceleration, negative acceleration, time 0, outwards. So let's just start with this. I mean, these can be a little bit tricky. It takes a little bit of time to get your head around, so I'm going to try to help you resolve this. So let's look at this. Let's start off with a velocity graph. If I have velocity, that's a flat line in the positive. There's two things that we need to interpret from this. One is the fact that this has no slope means that we're not accelerating. And the fact that we're in the positive range tells me that the distance is going to be sloping upwards. So anytime the velocity is in this part of the graph, if it's above this line, the slope up here is upwards. So I know, since this is a flat line right here, that's a flat line in the positive area, the flat line tells me it's not accelerating, it's a straight line. And the fact that it's in the positive range tells me that it's sloping upwards. It has a positive slope because it's a positive velocity. Now, what this doesn't tell me is where on the distance graph it is. This could be a positive distance value, or it could be here. Both of these here are possible from this one here. So what this communicates, flat communicates a lack of acceleration, that this line does not curve. The fact that it's in the positive region of this graph tells me it slopes in a positive direction. Now let's just undo these, if I can. So now let's go ahead and have this be in a flat line below here. So the fact that it's flat tells me that there's no acceleration, so that this is going to be, this variable over here will not have a curve to it. This line will not curve. It's not accelerating because it's flat. Remember, the slope of the velocity line tells me the change in velocity. The velocity is not changing, so I'm going to have a straight line over here. Now the fact that this is in the negative region of this graph means that this constant slope that we have over here is going to be in a negative direction. It could either be that or it could be that. So the two things that are being communicated, the fact that this is not sloped means that this does not curve, that this has no change in its slope. And the fact that this is in the negative region of the velocity graph tells me that this line slopes in the negative direction. Negative velocity means you are moving, you're displacing in a negative direction. Okay, well, what if it does slope? What if it slopes this way? Okay, what that tells me then is that because I'm in the positive range here, that tells me that I have a positive slope over here. It doesn't tell me where, but it tells me it's a positive slope. However, the fact that this is not flat, the fact that this has a slope to it indicates that we are increasing between here and here, that the velocity is getting higher. So think of it as it's going from less steep to more steep, and it's doing it in a positive direction. So that means I'm going from less steep to more steep in a positive direction. Now, what if, I'll do the other color, what if I had the same thing over here? Now, in that case, what I've got is the fact that it's in the negative region here means that I've got a negative slope. And since it's a negative slope, that means I'm no longer a positive velocity, I'm a negative velocity. It does not mean that I'm in this region of this graph. It means I have a negative slope. And that the slope is going to start fast and end up going towards zero. Because remember, this line represents zero velocity. So that means I'm going to move towards a velocity of 0. So what this would look like over here, and I'm going to put it in the positive region here, what this would mean is I have a negative slope that is becoming less negative as it goes downwards. So remember, there's two kinds of positive. These both represent positive accelerations. So both of these on an acceleration graph would show up here because they both represent positive acceleration. The difference is because this one is in the positive region, it slopes upwards, and it starts at a gentle slope near zero, and which means flat, and it becomes steeper as I go. Because the red one is in the negative region of the velocity graph, it indicates a negative slope. And because here it starts at a high velocity, which is steep, and ends at a very low velocity, which is very flat. Okay, now let's look at negative slopes. So if I have a negative slope here, or a negative slope here, what do they communicate? Let's start with this one here. The fact that it's in the positive region of the velocity graph means it's a positive velocity. So over here what that means is it slopes upwards. It's got a positive slope. It's a positive velocity. The fact that this is in the negative region of this means it has a downward slope, that it's a negative velocity. Regardless of where on this graph it is, this represents a downward negative slope. You're moving in the negative direction. Now, let's look at the difference between these two. Here I have a positive slope because I'm in the positive region, so it's sloped upwards, but it's going to start fast and get slow. So what that means is it's going to start fast and get slow. It's moving in the positive direction, it's an upward slope, but it starts with a steep slope and it ends with a very gentle flat slope, close to zero velocity. Remember, the slope over here is the velocity. So let's look at this one here. Here I've got, and I'm going to draw it in the positive region just to make a point that this does not mean you're here. This tells you what the slope is. The fact that I'm in the negative region means I have a downward slope here. So let's see, in this case it's going to start near zero, which is flat, and it's going to become steeper as I move forward in time. And it's going to slope in a downward direction because I'm in the negative region. So that means I have something like this. I start with a gentle slope, and I have an increasingly negative slope. That's how you interpret these. Now, in this case, since both of these here have negative slopes, both of these would show up on this graph like this, or like this. They both indicate a negative acceleration. So it's difficult to know from an acceleration which of these I'm dealing with. I don't, but I do know it has to be one of these two if I'm over here. So let's go ahead with this in mind and try to look at our homework. Okay, between here and here, we're sloping in a downward direction, which puts us on this region of the graph, the negative slope region, the negative velocity region. Now I'm starting high and I'm going low. I have a high velocity and end with a low velocity versus fairly flat. So therefore, how it should look would be I have a negative velocity that starts off high and ends up low. Now let's look at the second part of this curve. I now have a positive velocity. It's sloping upwards in the positive direction, which puts me in the positive region of the velocity. If you have an upward slope, you belong here. If you have a downward slope, you belong here. Now in this case, I start off close to zero in slope and I get steeper as I go, so therefore it's just going to look like that. I mean, if I draw it perfectly, I just have a single line going like this. And when I go to the acceleration one, all I have to do is I look and say, you know what? This is a positive slope on the velocity graph. That represents a positive acceleration. Let's look at our next one. Okay, I have a positive slope here. Since I have a positive slope, that means I belong in this region of the velocity graph. So now that I know where on the velocity graph I belong, the positive region, let's look at this. The slope here is very flat, meaning I have a low velocity. The slope here is quite steep, meaning I have a high velocity. So it should look something like this. Positive area going from low to high. Now let's look at the second part of it once I cross the line here. Now at this point what I have is I am still sloping upwards. So I'm still going in this general direction. which means it's still going to be in the positive region of this graph. However, in this case, I'm starting with a steep slope and ending with a not so steep slope. So I'm going from a high velocity to a velocity that's close to zero. So therefore, it should look something like that. Now, if I want to put this onto the acceleration graph, a positive slope represents a positive acceleration, and a negative slope represents a negative acceleration. Let's try our next one. Now, we're going to do something a little bit different. We're going to switch things up a little bit here. Let me just scroll up a little bit here. So now what we want to do is we want to transfer ourselves from a velocity graph over to a distance graph. So the fact that this is in the negative region here means we're sloping downwards on this one. It doesn't matter which region. I'm going to start up here. And the fact that it's flat means it doesn't curve. So I'll have a non-curving, flat, non-accelerating negative slope like maybe that. Okay, now what happens is we're still sloping in a downward direction. We still have a negative velocity, so this is still going to be going downwards. But instead of going down at a constant velocity, we're moving towards a slope of 0. And as we move towards a slope of 0, that means we have very little change here. So we're going to come this way. So I'm going to try my best to draw it like this. Let's see if I get it right. Something like that. I didn't quite get it right. Now, what does this look like on an acceleration graph? Well, over here we're going to find is that this region here represents a lack of acceleration. Since there's absolutely no acceleration, it's on 0. And then what happens is we have at this point here, we have some, the slope is upwards, which is the positive slope, so we have a positive acceleration at that point. Let's look at our next one. We're going to do the same thing again. We're going to try to go ahead and transfer it from a velocity to a distance one. So what we have here is we're in the positive region, so we have a positive velocity, which means we're sloping upwards. Now we're starting with a high velocity, which is steep, and ending with a low velocity, which is with 0 velocity, which is flat. And we have to be in the positive region, starting steep and getting flat. That'd be something like this, I think. Now let's look at the second part of it. Now we have, in this case, we have a negative slope because we're in the negative region of this graph. And we're going to start at a slope of 0 and get steeper as we go. So we're now going to move in a downward direction, starting flat and getting steep. So it's going to look something like that. Now, how does this look on an acceleration graph? Well, we notice we have a constant negative slope, so the whole time we have a negative acceleration. Let's try our next one. On our next one, let's see what we have here. We are in the positive region, which means we're sloping upwards over here, and the fact that it's flat means that there is no acceleration associated with this. So, and it doesn't matter where on here, so I'm just going to change things up. I'm just going to go like this to make a point. It doesn't matter if I cross that axis. This just means that it started behind me and now it's in front of me. Or to the left of me and now it's to the right of me. Okay, so now what happens at this point here, we get an upward slope. Now, so that means it's accelerating, and it has a positive slope, so it's going upwards, and it's going to become steeper as we go. So whatever steepness we have here, it must become even more steeper. This is going to be hard for me to draw, but that's that's how I'm going to draw it. Okay. Now, what does that mean in terms of an acceleration graph? Well, what it means is here there's no acceleration, so it should be flat on 0, which it wasn't quite. I wanted you to see it. And here it's sloping upwards, so it has a positive acceleration. So if you notice, what's weird is, just look at this, just to make my point here. Look at this one here, and look at this one here. They're pretty much the same. But look what we get here. They are not the same. So it's very difficult to go from an acceleration time graph to a distance time graph. But if you notice, this here and this here, they do look the same. The only difference is one is above the line, or one is above in the positive region, and one is in the negative region. Well, here we go. All right, we have a positive slope, which puts me in this region of the graph. It's starting steep and becoming less steep, which means I have to start with a high velocity and with low velocity. So what I've got is something like this. Now let's see what happens next. Now what I have on this region is I have a negative slope, which means I have to be in this region of the graph because I have a negative velocity. Since I have a negative slope here, it's going to start at a slope of 0 and become steeper as I go. It's going to start at 0 velocity and go more this way. So it just looks like a straight line if I had drawn it correctly. And since the slope here is continuously in a negative direction, it's simply this on that graph. This next one is so mean and brutal. Oh my gosh. Let's just try this one here. You're going to hate me for this one. Oh, wow. Alright, let's just look at this part right here. This part is in the positive velocity, which means we're sloping upwards. We're starting steep and we're ending at 0. So we're going like this. Then what happens is, now we've moved into the negative region of this slope. Negative region means we have a downward slope. We're starting at 0 and getting steeper, which means it's this. Now what happens is, at this point here, we still have a negative slope. We're still going downwards, but now we're going to go from high velocity and aim towards 0. We're going to go from steep and go towards flat. We're going to go from steep and go towards flat. Then what happens is, now we're in the positive region, which means we have an upward slope, and we're going to start at a very flat line and become steeper as we go. Like that. It's a sine wave. What do you know? Okay, so how do we do this then in terms of the acceleration graph? Well, it turns out pretty easy on the acceleration graph, and here's why. If you notice, I have a negative slope between here and the dashed line, so therefore I have a negative acceleration. And starting here, I have a positive slope, so that means my velocity is becoming greater, which means we are going to have a positive acceleration. Well, let's keep going. I don't know about you, I love these. Alright, what do we have here? We are moving in a negative direction here. Well, we have a negative slope, which means we're going to be in the negative region. It's starting steep and it's becoming gentle. So therefore it's starting at a high velocity and ending at a velocity of 0. Now here we have absolutely no displacement. We have no velocity. A flat line means no velocity. So our velocity is going to stay 0. Now here what happens is we have a negative slope, just like we had here. So we're going to stay in the negative region here. It's going to start near 0. It's flat, and it's going to get steeper as we go. So it's going to be this. Now when I look at my acceleration time, what I have is, here I have a positive slope, so I have a positive acceleration. And then I have a slope of 0, so then I have no acceleration. And here I have a negative slope, so I have a negative acceleration. Let's try another one. Now this next one, it could be, we could do this lots of different ways. Let's see what we're going to come up with here. Okay, what I know is that here I have a positive acceleration. Okay, so that's all I know about this. So what I'm going to do is I'm going to build the velocity time graph and then transfer that over to here. So what I know is I have a positive velocity here. I mean, I have a negative acceleration here, which means a negative slope. Okay, a negative slope could mean just about anything. So I'm going to do my negative slope here. That would work. And then I'm going to have a positive acceleration. It means I have a positive slope. And then here I have a negative acceleration, which means I have a negative slope. Now, I could have done this several different ways, But let's see what I've got now. Because I did it this way, this is in a positive region of the velocity, which means I have a positive slope, starting steep and getting gentle. Starting steep and getting gentle. Okay. Now, what's going to happen is I still have a positive slope. But now this positive slope is going to start gentle and get steep. Okay, so I have like that. And then what's going to happen is, let's see, I still have a positive slope. I'm still in the positive region of my graph, but now I'm going to start steep and go flat. So I'm going to start steep and go flat. So look at that, it's like I got a snake, really. What I got is, what I got is steep, flat, flat, steep, steep, flat. And you could have done it a different way. If I had chosen to draw this one different, if I put this negative acceleration here, it would look very different. Okay, so you could go with something very different from me and still be correct. Alright, now at time 0, the motorcycle is 50 meters to the left of me, and so it says, consider only the horizontal component of motion. So, like in cases like this, where I have a ball going up, that doesn't matter. All that matters is this motion here. So I have a motorcycle, and we're going to use left as negative and right as positive. So I have a motorcycle that's 50 meters to the left of me, so that's the negative direction. And it is going 20 meters per second, so that's a constant rate of speed. So I'm going to have a constant rate of speed, which means since this slope here is positive, since it's coming at me, I'm going to be in this region of the graph because it's a positive slope. But since it's a constant rate of velocity and not accelerating, this line has to be flat, which means the acceleration is 0. Now, time 1, the motorcycle is directly in front of me and begins to increase its speed. So it's going to go faster, which means it now has a positive acceleration. And that means its velocity is going up. And that means this is going to start at the slope it's at and curve upwards. So this is going to be a little bit tricky to do, but I'm going to try to go. That's supposed to be an upward curve. It's hard to draw. Okay, now what happens is the motorcycle at time 2 hits its brakes and slows down to a stop. So let's just look at the velocity. So the velocity is going to go from here down to a stop. That means it has a negative acceleration. Since this slope is negative, it has a negative acceleration. And that means since I am still in the positive region of this graph, it still has an upward slope, but it's going to start steep and become gentle. So it's going to go like that. So really what it should look like is, if I get it right, it should be flat, curving upwards, and curving this way. Let's try our next one. Alright, so what I've got is a bowling ball that is rolling this way. It's going to slow down and then continue at a constant rate. So to start off with, it's going at a constant rate of speed in a positive direction, so it has a positive velocity that is not accelerating. Since it's not accelerating, this is 0. Since I am in the positive region of this, it is going to be an upward slope, and it is not going to curve because it's flat. It's not accelerating, so it's just going to go like this. Now, when it gets to here, what's going to happen is it's going to slow down. So it's going to start fast at 12 and end up at 6. So what that means then is the velocity, now the velocity is never going to become negative. It never ends up going the other way. So let's just look at the velocity. The velocity is going to get smaller. And so that means then, but it's still in the positive region. Now the fact that the velocity is getting smaller means I have a negative acceleration. I have a negative slope, so I have a negative acceleration at this point. And let's see what happens here then is I still have, I'm in the positive region of the slope, so this is still sloping upwards, but what's going to happen is the slope is going to move more towards 0, more towards flat. So what's going to happen is it's going to start curving this way. And then what happens is it's going to continue traveling at 6 meters per second, so half the speed. So basically, what happens is this slope should end up being half as much. So it's going to end up having less slope here. It's still supposed to be upwards. So here it was steeper, it curved, and became straight again, which is kind of hard to draw, to be quite honest. It's a lot easier on a velocity time graph. Hey, it was at 12, it slowed down, and now it's at half of what it was. And because it is not accelerating when it's traveling on this flat surface here, the acceleration goes back to 0. Now I've got a ball that's initially at rest, and it is going to begin to roll down an incline. So but now remember, it's going to the left, guys. So remember, this direction is considered the negative direction. So what happens is it has a velocity of 0, and its velocity is going to increase in a negative direction. So its velocity will start at 0 and increase in a negative direction, which means it's going to start here and it's going to have very little slope and become more sloped as I go this way. Then what happens is it's going to travel across a flat surface, which means it's not going to, you know what, I wish I hadn't drawn it the way I had before. So because it's flat, it's going to continue whatever velocity it had at the bottom. Now, what that means then is that its velocity will stay wherever it is here, which unfortunately I drew too steeply over here. I got a little bit crazy there. So I'm going to take this one here and see if I can undo it. I don't know if I can. I'm going to try to make this. No, that's not going to work. Never mind. So what I'm going to do is I'm going to do this one in red. So maybe, okay, so I went a little bit too crazy with that. So now it started flat and became a little more steep, but now it's going to continue at a straight line. It's no longer curving. That's what I needed to do. And then, well, let's see what happens next. Then it's going to go up an incline, and as it goes up this incline, it's going to have to slow down. So its velocity is going to become less in the negative direction. It's slowing down in the negative direction, which means it's slowing down but still traveling in the negative direction. It hasn't turned and started going up yet. And then it's going to continue once it gets to the shelf to go at a constant rate of speed. So the line's going to be flat but negative because it's still going in the negative direction. As long as I'm down here, it's negative. Now, what does that mean over here? It means it continues at whatever that line is. It's supposed to not be 0. It's close to, but not 0. So basically, curved, flat, curved the other way, and flat. Now let's see what that means in terms of acceleration. I have a negative acceleration here. A negative slope equals a negative acceleration. Then I have a flat velocity line, which means there is no acceleration. Then I have a positive. It's slowing down in the negative direction. So I have a positive acceleration at that point. And then it's traveling at a constant velocity, meaning I have, at this point here, it's traveling at a constant velocity. So a constant velocity means there's no acceleration. Okay, I admit this one's kind of mean. Alright, let's see what happens here. The ball is going to roll this way at 6, bounce off here, go this way at 6, slow down to 2, and keep going this way. Oh boy, this is trickier than you would think. Well, first of all, it's going in a positive direction. So this has to be moving in a positive direction. And it's going at constant rate of speed, so there's no curve here. So for between 0 and 1, we should have something like, say, this. Then what happens is it immediately, when it hits the wall, starts going in the negative direction. So it's going to get a negative slope. And notice it's going to displace farther than it started. It started here and it ends up farther in the negative direction. So now we have a negative one that's going to go past 0. So it displaces a little bit farther than the 0 point. Okay. Now what happens? Well, now it's going to slow down as it moves in this direction. So its slope is, as it slows down this way, this slope will become less steep. So it becomes a little bit less steep. and then it's going to continue traveling in the negative direction at a reduced rate, so at a lower slope, so the slope will stay constant from that point onwards. That's not supposed to occur. That's terrible. So the point is I had steep, it curved, and became straight at a lower slope. So let's see what that looks like for velocity. Okay, to start off with, we had a positive velocity. So the fact that we're this way puts us in the positive region. The fact that it's straight and not curved means that this has a flat slope. Boom. Now this is a really bizarre thing. It immediately went from having a positive slope to a negative slope, a positive velocity to a negative velocity. So I had to jump from here down to here, but it's still traveling at the same speed. It's not accelerating. It changed direction, so it accelerated in that regard. But it's just traveling. Whatever the velocity is here is what the velocity should be here. This line should be just as far below this line as this one is above it. Now what happens is it's slowing down in the negative direction, which is the same thing as having a positive acceleration. So it's going to go like this and then like this at a constant rate of speed. If you want, I suppose you could do that. Alright. Now, what does this look like on the acceleration curve? Well, here there's no acceleration, and here there's no acceleration, but here I'm changing direction very rapidly. So there's a very brief moment of huge acceleration here, and that acceleration was in the negative direction. So here's how I'm going to represent that. It went like this, and I'm just going to put like a little, just a spike down there, and then go this way, showing that there was just this brief moment of negative acceleration. Now what happens is, at time 2, I get a positive acceleration. This is sloped in a positive way. Even though it's moving in the negative direction, it's slowing down in the negative direction. So I'm going to put this up here. I have a positive acceleration. And then at this point here, it's no longer accelerating. It's traveling a constant 2 meters per second. So therefore, I'm back to 0 acceleration. That was kind of a stinky one. I apologize for that one. And if they thought that one was stinky, this one's stinkier. Okay, let's see what's happening here. To start off with, this ball is rolling at a constant velocity in a negative direction. So it's got a negative velocity that is constant. So what we have here is a constant negative velocity, and that would show up here as and it starts at, well, let's see, we don't know where it starts, so I'm just going to have it come down this way. It's got a negative non-accelerating velocity. Now when it gets to this point here, it's going to speed up in the negative direction. Remember, this is the negative direction. It's going to start going faster this way. So that means I have to curve it in this direction here, which is hard to do. You know what? I don't like the way I draw. I'm going to do this in red. So I'm going to go with less of a steep, and now I'm going to make it get steeper. So it started off flat and it got steeper. Alright, so it is basically accelerating in the negative direction. Now what happens is, when it hits that wall, it suddenly is going to be bouncing in the opposite direction. So now its motion is no longer going to be in this region of this graph. It's now going to be up here in the positive immediately. That's why I'm saying things bounce. All of a sudden you jump up. But keep in mind, as it goes this way, it's going to be slowing down. So it's going to be moving towards the 0 line. So what I have to do here is really weird. I have to jump up and have it start moving towards the 0 line. But then it's going to reach this shelf and drift away this way at 1 meter per second. So that means that I'm going to end up getting close to, but not quite to, the 0 velocity line here. That's kind of ugly. Well, let's see if we can do this over here now. What happens here? Well, what happens here is I immediately went from having a slope that was in the negative direction to a slope that's in the positive direction. So I have to immediately switch from going this way to going this way. And I am my slope is tending towards 0, which means getting flat. So the curve has to be kind of in this direction, but not quite getting to 0. So I have to go like this. And then what happens is, wait a second, something happened on my graph here. Okay, it should go up this way, curving this way, and then travel at a constant velocity. So basically what this curve looks like is it should be flat, curving downwards, immediately curving upwards, and then continuing at the same. That's really hard to draw. Well, let's see what happens over here with the acceleration part. So to start with, there's no acceleration. Then it begins to pick up speed in the negative direction, which is to say it has a negative acceleration. Now what happens here is there's this brief spike, and then we continue our negative acceleration. So I mean, if we want, we could say, well, there's this brief spike towards the positive, but then we continue with a negative acceleration. And then what happens is, when it makes it to the shelf here, it stops accelerating, so we had to go up and go like that. Ugh, that's an ugly one. I'll just do this to make it all look like one continuous thing. Okay, just one more and then we can be done, folks. I can go to bed. Good golly. Alright, a ball is thrown upwards, leaving the hand at time 0, reaches its apex at 1 second, bounces off the floor at time 2, and reaches its apex of its bounce at time 3. You know, this is pretty easy for me to draw this way. So, but you know what? I'm going to start off showing the velocity. So if it leaves my hand and it has a velocity, now you know what, let's just see what it looks like. It looks like this. I threw it up, it reaches apex, it hit the floor, it bounced, it reaches apex, and came back down. Alright, that's what just happened. How does this look like from a velocity? Well, let's see. The slope is positive, which puts me in this region of the graph. It's starting steep and becoming gentle. It's starting steep and it's becoming gentle. At the apex, it reaches 0. We reach 0. Now it has a negative slope and it's starting at 0 and becoming steeper. It's got a negative slope starting at 0 and getting steeper. So even though this one curves this way, the whole time it was in the air, it had a negative velocity. By the way, 10 meters per second. Now what happens when it hits the floor? Well, it immediately switches and has a positive slope, if you notice. Okay, so now it's going upwards. So that means I have to jump to the positive slope region of the graph. But it's slowing, but it has a steepness to it. So I have to jump up higher to show I have a steep velocity that's getting less steep. So I have to jump up and then come back down, because at the apex I have a velocity of 0. Now beyond the apex, it's going to end up having a negative slope, which puts me in this region of the graph, but it's going to continue to go from 0 to steeper at the same rate. Let's see, let me draw it right there. So get used to this. This kind of funky pattern, that's what bouncing balls look like. How does this look like from an acceleration standpoint? Mercifully easy. If I look here, between time 0 and time 2, I had a continuous negative acceleration. And then I had this brief spike and a continuous negative acceleration. So the way I would draw it is I'd say, well, I had negative acceleration, I had this weird little spiky thing, and a negative acceleration. And that's your homework, folks. I'm sorry it's such a long video.